Let's begin our topic with the intermediate value theorem. Normally I like to kind of set up the definition of it, but for this particular case, I'm going to jump right in and give us the idea of what the intermediate value theorem is saying. And I'm going to lay it out, and then I'm going to give you a visual representation, because if you get bogged down by the jargon of what it's trying to say, it may not be as clear. But if you actually look graphically or visually at what's happening with the intermediate value theorem, it actually makes all the sense in the world. So let's go ahead and state what this intermediate value theorem, or IVT, is really saying. What the IVT says is that if f of x is a continuous function, and so it's going to rely on continuity, which we've talked about here in Unit 1. If it's a continuous function on the closed interval a to b, and that's why we did a lesson earlier in Unit 1 about continuity over an interval. So if this is true, that the function is continuous on the closed interval a to b, and let's say that d is a value between f of a, in other words, the function value at a, and f of b, so the function value at b, then the intermediate value theorem, or IVT, guarantees that there is at least one value which we'll call C, in the interval AB, such that f of C is equal to this value D that we addressed earlier. And so right now, that's all you know. That may not mean just a lot to you. Let's do a graph and really kind of understand what it's saying. And you'll see why it makes perfect sense, and you'll also see why continuity is a really big staple of this theorem. So I'm going to draw a sketch of just kind of an arbitrary graph. I'll let it be in the first quadrant, but it doesn't really have to be. And what I'm looking for is I'm looking for a function that is continuous on the closed interval a to b. So let's figure out just kind of an arbitrary a to b. Well, I can say that if it's a continuous function, then it's defined on this closed interval a to b. So somewhere I have a value, and at a, that value is equal to f of a would be the function value at a, and then I'll just place f of b somewhere else. They don't have to be increasing from left to right. I'm just kind of giving you an arbitrary idea of what's happening. Here's what this theorem says. If d is any value in between f of a and f of b, so we'll do this one here in blue. Let's say that we have some arbitrary value d. If this function is continuous, in other words, on this entire interval, I have to go from f of a to f of b, then I can't do that without at some point having my function equal to this value d. Somewhere in between here, I can definitively say that the function is equal to d. And it hinges on the idea that it's continuous. If it didn't have to be continuous, I could say, well, I could go here, and then I could jump up here. I could kind of jump over that line, if you will. But because it's continuous, I can't go from f of a to f of b without crossing this value d. In fact, I would cross every single value in between f of a and f of b. Another thing that's worth noting here is that it says there's at least one value c, meaning I could jump across this line multiple times. There could be multiple times where I equal this value d. But because it's continuous, I have to cross over at least once at some value that we call c, which is some value in between a and b. And you can kind of see just visually what's happening here. And in fact, I'll go ahead and let it happen at d like that. That's what it's saying, is that somewhere, if I draw any kind of continuous function, I have to at least have the value d one time. And you might be thinking, okay, yeah, that makes sense now that I see a picture of it. What do we get out of it? And the thing that we actually get when we look at the intermediate value theorem is it gives us some ways to verify some statements we want to make about functions. There's going to be a time where maybe we want to say, hey, yeah, this function is equal to 0. We may not know where, but at least we can prove that somewhere a function equals to 0 or equals some other value. And it's actually a very helpful technological tool when it comes to solving equations that maybe don't have a solution that we can work out by hand. We could actually do some computer programming or something like that where we could find a solution built on this idea of the intermediate value theorem. So this is what it states. Once again, I'll read it here. F of x, if it's continuous on the closed interval a to b, and if d was some value between f of a and f of b, then the IVT guarantees that there's at least one value c on this interval from a to b where f of c is equal to d. And that's the intermediate value theorem.